In fact, before we delve into the meat of the presentation, let me just do a quick survey. So I see there are quite a few folks here in the session today. So let me get an idea of the people's background. For those of you who have had practical experience with AI machine learning, if you could just please respond with yes in the chat window. Please type yes if you have had any kind of practical experience with AI machine learning. Any domain, type of application, please type yes. All right, I see a lot of yeses coming in. Excellent, thank you. Now, if you have heard about Edge AI on-device machine learning, please do the same thing, type yes. Just having a slight idea of what Edge AI on-device machine learning is. Okay, I see some yeses, I see some nos. All right. Good, good. Now let me, okay, perfect, thank you. Now let me get even a bit more targeted. If you have ever built an application, a product that would be leveraging training at the edge, training a machine learning model on an edge device. Definitely no. Good, that's exactly why we're having this session today. Oh, I said a yes, that's excellent. I don't see that around a lot. Perfect. All right, thank you so much, folks. That's really helpful. I will really do my best to make sure that everybody can get something out of this session. And this is just very helpful for me. Again, as I go with the presentation, please do feel free to post your questions. We'll have a separate Q&A session, Chris. I'm sure I'll be able to address some of the questions just in the flow of the presentation. The ones that I don't get to, we will make sure to address in the Q&A. So as Bill mentioned, please post your questions in the chat box. All right, now with the logistics out of the way, let me give you a proper intro. So my name is Vera Serdiukova, and until recently, I had been building applications with learning at the edge since about 2014. I have witnessed companies toy around with learning at the edge for years without, ever making that to production, as well as Edge AI truly revolutionizing businesses and products. So today, I would like to share some of those insights with you. And one thing I should mention just to preface those insights, that all of the opinions are solely my own. This is really the takeaways experience from the past 7 years or so. Totally not representing my current or past employers, but yeah, I think the observations I have had are quite reflective of the industry and state of the art, both in terms of technology and business. So happy to share with you all today. All right, now that the legal disclosures are done, something that I saw recently on LinkedIn and that really sparked my thought process is this quote. It went something like this: "A bad decision well executed is better than a brilliant decision poorly executed." Now, I found this quote extremely dubious. Like, why do we have to choose between two evils? Bad decisions or poor execution? So in this talk today, I would like to share with you how to make good decisions when it comes to training at the edge, as well as achieve its brilliant execution. That said, today we will focus on 3 points. 1, how to decide whether you should train at the edge, as opposed to other options, such as, for example, cloud. 2, some of the big decisions that training at the edge would entail. And ultimately, what does it take to build a holistic user experience and UI for a product leveraging training at the edge? Sounds like a plan? All right. Before we go into all these 3 points, I just want to make sure that everybody here is on the same page, because, you know, edge AI is an extremely fuzzy topic. Everybody understands it differently. So when I say edge device here today, I mean a device whose compute, memory, energy resources are constrained and cannot be easily changed. That's our definition. And by learning, I mean training or retraining of a machine learning model on edge device, right? So training as opposed to inference. We're going to be focusing on training/learning today. All right. Okay. That said, I noticed a few of you have had some experience with edge AI, and it's not going to be news for you to hear that edge AI is seen a bit as a panacea these days, right? It's been praised for its fast and secure operation, for its ability to preserve privacy, as well as for its ability to be autonomous in a way, right? Non-reliant on network connectivity. I would say that pretty much all of these qualities, except for perhaps speed, are true for training at the edge. Nevertheless, you know, you could argue that, okay, pretty much all of these benefits could be achieved with other more traditional techniques. For example, you could customize an application, customize a capability to your user by and do that in the cloud, right? You don't need to go all the way down to the edge. That leads me to my point that the superpower of training at the edge lies really at the confluence of these benefits. Because you are able to shape this really radically new value proposition. A product able to adapt to unique and distinct user, device, or environment data locally, with the private data never leaving the device. That sounds quite appealing, doesn't it? All right. Well, does it mean that all of us should jump on the edge training right away? I guess that's something we'll have to figure out as today, and it might be a way longer process for a few of you. But one thing we'll do today is similar to a game a teacher friend of mine introduced me to a while back. How many of you have heard about should I or shouldn't I game? Okay, not many people. So it's a game for high school students that actually helps them make better social decisions by understanding the context and reflecting. Now, I'm not gonna put you in the shoes of high school students today, but we're gonna go through a somehow similar exercise, essentially asking ourselves questions on where we and our products are today, and understanding whether training at the edge is a good fit for us. And by us, I mean each of you individually, because I'm sure all of you have very different contexts and goals. Before we do so, I want to make sure that everybody has at least kind of a basic understanding of what training at the edge is and what goes under this umbrella. So broadly speaking, there are 3 buckets of training at the edge. The first bucket, and this is more of kind of technical take from a PM. So this is pretty rough. So the first bucket is what we call model refinement. The idea here is that you have a base model that is trained usually in the cloud or on-prem, and then this model is adapted to unique user or device data locally, right, on each specific device. So that's model refinement. I would say this is the most typical approach you see in the industry. The second bucket is collaborative learning. The most, I would say, famous, recognizable representative of this family is federated learning. This approach is slightly different. So what happens here is that you have this global model that is, again, updated on devices, but then you send the model update to a central server. And these model updates are used to build a better global model that is then consecutively sent to the entire network of the devices. So the idea is that all of the devices in the network can benefit from these universal improvements. And what I said just explains the federated learning technique. Obviously, there are a lot of permutations of this technology, right, that go under the collaborative learning umbrella. The third bucket is perhaps the most intuitive one. It's training exclusively on edge device. So no network effect, no cloud or prem, whatever. You just train specifically on the edge device. Okay, so takeaway, there are a few different techniques, but essentially each of them leverages some sort of training on the edge device. Okay, I think that should have been like a pretty solid primer to get into discussion of whether we should actually train on edge device, whether that's an option you should consider for your product and your business. The first question to answer is whether you have a good knowledge of the hardware requirements of the target devices that would be performing edge learning. And by requirements constraints, I mean memory, compute, and power. Now, why is it critical? The thing is that with training at the edge tends to be significantly more expensive, like in the sense of computational intensive, expensive, compute expensive, than, for example, inference. Let me give you a couple of examples. So some of the devices that I use for training at the edge these days are, for example, NVIDIA Jetson Nano, right? Then smartphones such as, for example, Pixel 2 and above, iPhone 11 and higher. I don't want to say that these are devices exclusively capable of supporting learning at the edge. However, it might give you an idea that a lot of times the requirements in terms of hardware might be pretty high-ish, but even if it's not the case for your application, at least you should know what the threshold is, right? What the requirement is, and that and ensure that the target devices will actually support this device support this threshold. Unless this is the case, I would say going for edge training is just honestly a bit too risky. You might end up with making a big investment without that being just feasible, right? However, you might also be in a lucky situation where you have a freedom of selecting your own hardware. Or who knows, maybe even going co-design route, right? Co-designing hardware and software. If so, lucky you. I would say that's really a special situation to be in. However, one thing to be aware of here is BOM, bill of material. The reason I mention that is that, for example, for modern smartphones, SoC, system on chips, might account for as much as 7 to 10% of retail price. Okay, everybody did their mental math? That can be quite a bit, right? Again, depending on your application, you might not require a sophisticated SoC, but as you design your hardware, you might just want to think, is it something that is financially sensible for you and your users? If not, then again, maybe you're better off just going with a cloud avenue and then distributing cloud costs through, for example, subscription models, right? This way you preclude this kind of balloon payment for hardware and you distribute costs over time. That's also an option. However, if hardware is really not a problem and financially makes sense for you, then we're up for the next question. The next question is also a crucial one. It has to do with having enough quality data for training. So as I said, training at the edge is unique, right? Of course, data does not leave the device. And the amount of data you're going to need is obviously going to vary between applications, even within the same application. For example, if you do image classification, let's say you want to train solely on device, then you might need really thousands of images per class. However, if you're doing retraining, then you might get away with like 3 to 5 images per class, right? Thousands versus single digits, huge difference. But you really want to make sure that you can acquire this data through their device. It might already be there, for example, through your user's past activity, or you might need to obtain it. For that, ask yourself a question like, is the general feasibility met? For example, you need image data. Does your device have a camera? Things like that, right? Of course, if not, then it might be a bit challenging. Another point here is not just having data, but having quality data. Because with the data not leaving the device, you as a developer will have limited opportunities to prepare and label the data. So the data you obtain should be good enough for you to be able to train. Yeah, if the data requirement is not met, then unfortunately, the basic prerequisites are just not there, right? However, if hardware constraints are solved, data is solved, the next point is tooling. Those of you who have some experience with HA know that it is just a nascent field, right? Learning at the edge is even less kind of developed, at least industry-wise, right? So not a big surprise, tool stack is not the most mature one. Both Apple's Coral and Google's Coral do have certain support for training at the edge. That's good news. Not such excellent news that this support is still rather limited to specific, for example, algorithms, applications, etc. TensorFlow Lite has been showing some signs of introducing a training pipeline. However, to my knowledge, at this time, the support is still limited to pretty much like a single example. That is, again, pretty specific. Let me put it this way. So I would say unless these pretty limited tools available off the shelf fit the bill for you, you should be prepared to either have, strong expertise yourself. And when I talk about expertise, it's really a combination of, more or less kind of traditional machine learning as well as embedded engineering. And it's really the confluence of this expertise. Or it might just require a bit of investment, right, to build up technology when you don't have adequate tooling in place. Again, if that's not an issue, good for you. If it is an issue, perhaps it's an investment that might be just a bit too much. However, again, if tooling is not a big deal, then congrats. I would say those things are really kind of key prerequisites for training at the edge. So, just technically speaking, right, we didn't get to the deep business part of it, but technically speaking, if you have adequate hardware, if you can obtain good enough sufficient data, if the tooling works for you, that's actually good news. Because one, you can curb crippling cloud costs by pretty much outsourcing training to the network of target devices. And for those of you paying to, big cloud providers these days, that this can account for quite a bit. So that's first good news. Second good news is that you might be able to leverage this really unique value proposition, right? A product capable to adjust into unique and distinct user, device, or environment data locally, with this private data never leaving the device. And this is something that is just so rare in the industry and something that can really differentiate your product. So hopefully, at least a few of you said, that's something I would consider. If so, then let's figure out what exactly training at the edge would entail and what are the big decisions that you would need to make. The first one is perhaps just understanding what is it that you want to learn, right? I'm not going to go into the whole breadth of application that could benefit from this technology, but I would say I find people leaning on training at the edge in three broad scenarios. The first scenario is customizing application to the unique user or device data. And in my opinion, that's where training at the edge really shines. Because on the one hand, you can build this customization and or evolving experience. But on the other hand, you're able to maintain privacy. And in our world, there is quite a gap between these two concepts, right? So training at the edge is a very unique tool that is positioned to really bridge this gap. The second application is universal improvement, where you might want to take advantage of inputs from the network of devices so that in the end, ultimately, all of them benefit from the global improvements. And ultimately, independence, right? Here we're talking about autonomy, the product that is not reliant on network connectivity and can be absolutely autonomous, rather, no matter whether we're talking, for example, geographic autonomy, right, where it can be, I don't know, a device somewhere in the middle of tundra, right, operating on its own, or it's something that can just support areas with poor coverage, such as, for example, I know, driving Highway 1 or being in somebody's garage, things like that. Yeah, this is the third kind of broad rationale, what people would want to learn for and what would motivate them. Now that you know what you want to learn, the question is where and how does learning happen? And this is very closely linked to the first question. Because if you want to personalize or customize, most likely you'll go for model refinement. An example here, Apple Watch, right? That customizes what you see on its face. Okay, I'm not wearing a watch of any kind, but you get the gist of it. So it customizes what you as the user see on the face of the watch based on user behavior and interaction with the applications, right? In the second scenario, universal improvement, you'll most likely do collaborative learning, federated learning, anything of this kind. Take Clara by NVIDIA. So this is a federated learning platform, I believe, or a set of techniques. An example of how it was used, for example, in the medical industry is where a network of medical institutions working on breast tissue density analysis to detect, for example, any kind of abnormalities were leveraging this product to build a global better model while preserving, the private and highly sensitive medical data locally. And what they found is that the global model they built, the global technology they built, was actually performing better, right? So all of them were able to diagnose better. The last case is ultimate independence. From what I know, here your options are pretty limited because most likely you'll be doing training exclusively on device. It also means that other devices, other users will most likely not be able to benefit from your model. And frankly speaking, I'm just not aware of a single product leveraging this in production. So that's, I mean, there are advantages to it, this independence and autonomy, but from what I know, in many ways, it's just not very practical. Again, like when we're talking about production, right, versus academic research. If you know good examples of such products, please do pin me. I would be really curious to hear those stories. Okay, so now we're done with what, how, and where. We're on for when. When does the learning happen? And this topic has a few subtopics to it. First, how often you're gonna train. So training at the edge can happen just once, right? If your goal is, for example, to customize user experience at a certain stage, for example, when the user starts using the device. However, if the user journey you see is slightly different and you would like to provide a constantly evolving or improving experience, you might have to retrain every now and then. And when I say every now and then, that brings me to the topic of trigger, right? What actually prompts the training process? Here, think of it from two perspectives. One is the part of the user journey. For example, that might be an enrollment process, right? When the user is starting to use your device, right, a lot of times they go through enrollment process, device or application, I should say. And that might be a good time to introduce training to customize the experience going forward. Or you have enough data to start training. And again, enough quality data to start training. I should say that in practice, it's really a combination of those two elements. So both the timing in terms of user journey, as well as having enough data. Ultimately, device state. What do I mean by this? The thing is that training at the edge tends to be pretty computationally intensive. Again, as I've mentioned before, and I should say in comparison with inference, for example. Not all, but many of the household devices, such as, for example, again, smartphones, are not designed to run at top speed for extended durations of time. It might lead to battery drain, as well as overheating and eventually thermal throttling. You don't want that, right? So how do you avoid situations like this? You can time your training, for example, for when the device is idle or when the device is charging, right? And therefore, on the one hand, achieve training, but on the other hand, also avoid this unnecessary user experience glitches. Again, this might not be an issue depending on what technique you deploy. You might also be able to do it just on the fly, but a device state is something to consider here. A pro tip here, to my knowledge, Apple's Coromal actually allows you to set training time to when the device is charging. That might be a pretty handy shortcut to getting that sorted out. All right, the last question I will address here is the role of the user in the training process. And the answer here is it depends. Because your user might have, the application might be explicit, right? And the role of the user might be explicit. For example, the user might act as a human in the loop, helping you to label the data that will be used for training at the edge. Or the user might have a bit of a passive role by merely producing the data. However, they might not even be aware of the training, retraining process happening. Or the user might not be involved at all, because, for example, you're learning some patterns that just have nothing to do with the user interactions with application or the device. So it really depends on what your application is like. But as you design and build your application, you might just want to give it a thought. What is this role that the user would be playing, or you might need or want them to play? Okay, I should say we have gone pretty far theorizing on whether it makes sense to train at the edge, as well as discussing some of the critical decisions training at the edge would entail. So what I would like to do now is get a bit more practical and talk about the what it takes to build a comprehensive user experience around for a product that would be leveraged in training at the edge, right? How do we actually design not just technology but really product around it? I should say that there are many considerations to it. Also, can understand you're using customer needs, all of this, fancy product stuff that I won't be delving in today, as well as, business model and things like that. I think what people find more practical is specifically the UI UX aspects. How are applications with training different, and what needs to be done to kind of accommodate the intrinsic characteristics, right, that might be different from other underlying technologies. Okay, another fun fact I just have to share with you all, something that I learned recently and something that I'm still processing. Did you folks know that there are like 300 breeds of horses in the world? Okay, like those of you who have cameras on, don't look like too impressed. I don't know. I didn't realize there were this many. 300 sounds like a lot. I could not just mentally imagine. One thing that does beat this number is the number of edge learning pipelines out there. So just from my experience, every edge learning pipeline is different and unique. Again, many ways due to immaturity of the industry. But one thing that is consistent across all of them is the need for data and the need for quality data, right? Because again, training is going to happen locally, and you will have limited ways to get the data available. So as you design an application leverage and training at the edge, your first job, and this is really your primary job, is to ensure that the data is available. The data might already be there, right? Your user might already be producing it just through the existing behaviors. Would that be taking pictures, or for example, listening to music, or whatever that is, typing text, or you might need to introduce a routine that would specifically guide them to produce this data. Take a Siri enrollment process, right? That's exactly what it is doing. It is prompting users to provide data, sufficient quality data that would be used to train the model or retrain the model. Now, once the data is there, you might need, again, depending on machine learning technique you're using, you might need to label this data. And again, you might have to do that explicitly, where, for example, you ask your user to help you by being a human in the loop. An example here, let's say you're building a photo album application, right? And you might prompt your user, hey, what is the name of the puppy on this picture? Something of this kind, right? That's something that would kind of generate labels for your data. Or you can do that less explicitly by, for example, connecting for example, biometric data user provides to the already existing user account, right? You are not asking for anything new from the user. However, you're able to label the data by connecting these dots. The next thing that I see developers finding pretty handy is giving the user the ability to control training process, starting, pausing, or ceasing it altogether. Again, for example, in the example of that photo album app, you might allow them to put the pictures into different albums depending on who is portrayed on the pictures, right? Who is shown on the picture, who appears on the pictures. Or you might allow them to customize the application to their profile. In all of these examples, clearly highly dependent on what you want to achieve. But with training, I would say it's particularly useful because you're also giving the user to kind of the control of understanding what is happening in terms of the experience. And more importantly, I would say a lot of times that also ties to the data they provide. And a rule of thumb for anything data related, always inform the user what data is being collected and what it is going to be used for, right? So those things are kind of parts of the same game. Now, things happen privately is definitely very advantageous, right? And in our world of any kind of private sensitive data leaking, unfortunately, way too often, this is incredibly valuable. However, the flip side of it is that as a developer, for training happening locally on the device, you have pretty limited visibility of things like what kind of model is trained, and how it is performing over time, for example. And for those of you perhaps with a bit more experience in AML, you know that there are things such as, for example, concept drift, right? Where the model that performs well today might be performing not so well in, 2 years or so. So a lot of things can happen. You as a developer will have most of the times pretty limited visibility. So what you would want to do is to build guardrails around it. And those guardrails can come in a few different ways. One way is to give your user an ability to report report poor performance, right? And a lot of times, of course, they won't know that it's the model performing poorly, but report poor performance of a specific capability. Another way is also to inform them when something changes. So remember our example of a photo album app, right? Let's say that after retraining, the model actually got better, and like, what a surprise. In the past, a picture of a puppy was classified as a cat, right? And it was put in the cat album, but now you know that it's a puppy. So say your app moves this picture from a cat album to a dog album, you would want to inform the user about it. Again, this gives you like a way to communicate with the user better and build trust and build and potentially guardrail against like changes that might be, incorrect. That brings me to the point of course correction, right? Course, again, limited visibility. You want to make sure that there is some fallback scenario for a user to rely on in case something is going not quite as planned with your model. Here is something that many of you might be using day to day. That's Google's Gboard, that actually is built on federated learning. And in addition to providing word suggestions, right? Or like autocomplete suggestions. A few things you might want to know, you might notice. One is that it gives you options, right? To you as a user, it gives options. And two, you can always go to manual mode by typing in without autocomplete. So those are some of the examples of these fallback guardrails that might be helpful in just compensating for this limited visibility you as a developer would have. Okay, I guess that's been quite a bit to process. We've gone through a lot. So we went through a framework, right, that will hopefully help you all to decide whether training at the edge is something to consider for your product and your business. We also talked about some of the big decisions training at the edge would entail. And ultimately, we discussed what it takes to build a cohesive and holistic user experience for an application leveraging training at the edge. I really do hope that some of these bits and pieces will help you make excellent decisions and also achieve their brilliant implementation in your products. So thank you all, and I would be happy to answer a few questions. I know that we only have about 5 minutes remaining, so let me take a couple, and then if there are other questions, please just do reach out to me directly over LinkedIn, and I'll be happy to take it offline.
Great, thanks Vera for the presentations. I know you have a hard stop at 11 o'clock. We have about 5 to 6 minutes for the Q&As. I see I already have some questions in the chat. Maybe you can just go through them. For those one, you can post your question in the chat, or if you feel comfortable, want to speak to ask questions, feel free to raise a hand. I will unmute you.
Yeah, let me just start taking them one by one as they were appearing in the chat. And if there's something I miss, again, please just reach out on LinkedIn. So first question I see is how to productize the conversational AI beyond chatbot. So I'll be talking, specifically in terms of training at the edge, and I guess some of the benefits I see here. I think the first question to answer is what is your objective, right? Why would you want to take it to the edge? Are you trying to, for example, customize the experience, right? Where each user, for example, gets a different set of interactions, right? Or is it that you want to, for instance, learn from individual users in order to achieve the overarching experience? I think in practice, I've seen more examples of the first case, and some of the excellent examples from the industry is, for example, by seamlessly customizing using users' biometric data. So for example, when you say, hi, I know Siri, whatever, not making any explicit product references here, the system will induce who you are, right? Or it's Vera speaking to the system, and it might already have learned some of your past preferences. For example, that you are a loyal customer and things like that, right? If we're talking, for example, about retail cases, or for example, if we're talking about banking, financial institutions, conversational AIs, it might use it also as the way to not just identify, but also to authorize you, and use it as a key to answer your questions related to, for example, your bank statement, something that might be more sensitive. So that's one example. Another example is, of course, improving the robustness of the system. Because if your user does not have network connectivity, you might be able to provide similar capabilities no matter whether they're, for example, in their house in the middle of nowhere or traveling, but the capability still remains robust. The next question is, in practice, the trained model might need to be updated from time to time. How to get it done in edge device by a firmware upgrade? So that's an excellent question, and I think it has a couple of sub questions to it, right? Whether we're talking about model retraining that needs to happen locally, just by using, for example, device or environment data, or we're talking about a new global model that would need to be updated. For example, you as the developer might figure out, oh, my initial model is just not satisfactory, right? And then you want to make sure that your users receive this update. So I would say first question is, again, I won't use the word trivial, but it's easier to achieve, because you might use one of those triggers, either, for example, once you get enough data, you might automatically prompt retraining, right? Or you might enable your user to retrain, things like that. The second one is way more complex, and I won't be lying to you, this is actually one of the most challenging problems in the industry, right? Because a lot of times your initial global model would already have this local updates, right? For example, customized updates for the user. And by say you do an update, right? You prompt a user to update the entire application, they get a new model. How do you transfer this customization level? So there are some tricks to it. I don't know developers who were able to achieve it, but it does require some level of ingenuity. That's not something you're gonna get from off-the-shelf tools. That's something that you'll need to, to do. And the last question I'll take, are there mixes of these cases? I assume cases such as customization and universal kind of improvement, I think. Okay, please correct me if you meant something different. I would say, in a way, I think most of them are. An example that most of us perhaps could relate to, for example, this autocomplete type of applications, would that be a Gboard, or Apple has a similar product where on the one hand it does learn your vernacular, for example, the slang you might be using, right? And it adapts to it. But on the other hand, it also helps the global system get better over time. So again, depending on the techniques you employ, there are definitely this mix and match, except perhaps for, training on device only. That one is kind of siloed and stands, it's a category of its own. All right, and I see we're at time. I did not do a good job answering all the questions, so please do reach out to me directly.